Hello, this is Zachary of ECE3641 coming at you live from the studio. So what is this project? Well, to start off, I began working on a game in Unity that was controlled by inertial measurement units, which can be used to track pitch and roll angles of the real world. So, I decided to incorporate it into my final project, which will make use of controlling a robot arm with, well, my arm. I 3D printed this robot, shout out to Hogero for the model, and I'm using two ESP32 microcontrollers, one to control the robot and the other to read my arm. The two ESP32s communicate with each other wirelessly, no strings attached. In the code, I have commands that can be sent to the robot, which can set the joint angles of the robot, show the gripper's position, toggle inverse kinematics, open and close the gripper, and so on. The first command I will go over is moving the joint angles separately through the console. So, we will move the third link to 0, doing so. J, choose link 3. I will set that angle to 0. There we go. Now I will print out its position. So we will choose P. There we go. X is -75, Y is 100. Links 1 and 2 are both 50 millimeters, while the third link is 75 millimeters. Reason for that is being I want the gripper more so than like the actual length of the link. If we look here, X is -75 and Y is 100. Do the math. Link 1 is 50, link 2 is 50, that's 100. Funny geometry, you get -75. Next, I will control the robot through inverse kinematics. I have phi default to 0 relative to the x-axis. Links 1 and 2 will mostly be controlled through my arm, but are still relative to the inverse kinematics. So we will toggle the inverse kinematics like so. Does a little funny. Not sure if you guys can see that. No, pretty hard to see. We're just gonna wing it. So as we can see, the third link right here is facing upwards. That's the default value I set it to, so that's all good. Now I'm gonna move it up slowly so you guys can see that it is still facing upwards no matter how or where the joints are being set to. So if I slowly move that, you can see that it's still translating, but it's not rotating relative to the origin. Now I will show how the controller works directly with the robot arm. I had to do some funny math since the angle to servo translation isn't exactly 1-to-1. So let's get started. Choose D to directly control the robot arm. Hold it out, just to keep it safe. Now I'm going to raise this part of my arm up only, like so. Now I'm going to raise my arm up even more, like so. We can actually print out the where the position of the gripper is, like that. You can see, wow, that's actually incredible how I have it exactly like that. Let's go straight out. Try that again. Look at that, X is 175, Y is 0. That makes sense. A little wave there, Can even hold things, so let's say, get this pencil. Now let's open the gripper, use G. You guys can't see it, but it's open. This is gonna be a little difficult, but we will try anyways. It's going farther and farther away. Okay, close the gripper. Bam. Okay, maybe something a little lighter would have worked, but you can see. Let's try one more thing. Yeah, let's use this, whatever this is. Alright, let's open the gripper again. Hold it there. Yeah, leave it there. Closes now. And voila. Look at that. You can be a nuisance. You don't even have to be there. There are some other functions inside the commands, but it's more for tinkering around and testing. Honestly, this thing is just fun to play with, especially just smacking it into the ground like a giant karate chop. That's all I got for this project, so leave a like, smash that subscribe button, and I'll catch you all later.